All right, we're going to get started here. So welcome everyone. Thank you for joining. I'm Caroline. I'm from Wavefront, and I want to take care of a few quick housekeeping items before I turn things over to Nate. For your information, we are recording this session, and we will make it available to you after we finish the webinar. We will send that out in an email to you all tomorrow. Another item to note is at the end of the presentation and the demo, we are doing a Q&A. So if you have any questions throughout the presentation, use the chat box. There's a little icon on the bottom of your screen if you click the chat window open, and you can type your questions there, and we will get to them at the end of the webinar. So feel free to ask any questions throughout. And with that, I'm going to hand things over to Nate. So Nate, if you want to say hello, make sure we can hear you.
Yeah, hi everyone. Hope you can hear me. This is Nate Patwarden. I'm an SE system engineer for Wavefront by VMware. Joined the company this past winter, and my background is in both Linux and Windows infrastructure, being both an admin and an architect. And I'd like to show you some things today that will really expound on the value of Wavefront, and also I'll be showing a very specific set of demos from the product, so you'll get an understanding as to the robustness of Wavefront and how its value is called out for you.
Perfect, thanks Nate. So we'll have you get started then.
Okay, cool. So as Caroline had mentioned, this presentation, this webinar today is going to be based on a couple different parts. We're going to have about 5 slides. I don't want to be slide heavy. Then we're going to go into 3 cases as far as the Wavefront product goes, and then we'll do a Q&A. And to what you had mentioned earlier, any questions you have, just pop them into the chat, and after I leave full screen mode, we'll answer those at the end of the call. So here we go. So as you can tell here, there are 3 key categories: increased software dynamism and the rise of containers and microservices, continuous delivery and DevOps goes mainstream, and lack of unified visibility negatively impacts availability of critical services. The number one thing is that when I started in the IT realm a long time ago, everything was deploying a system or systems and an application or multiple applications, and then we would have a tool or 2 tools for monitoring systems and applications. With the rise of containers and microservices, we're not just talking about 100 metrics anymore, and I'm throwing that number out just as baseline, 100 metrics per second or whatever. We're talking about thousands of metrics per second. And also containers, while they ease the regular deployment of software, have that side effect of it complicates other upstream systems such as monitoring and alerting, because more things happen more quickly, and the traditional way of doing IT work has changed, and even DevOps for that matter, because I've technically done DevOps for many years, and even in that time things have changed. So continuous delivery and DevOps are being adopted in larger enterprises, and we used to do a monthly release or a quarterly release or a point release of things, require remediation as we went along, but you might be deploying code to production many times per day, and every time you deploy to production, you need that, continuous monitoring. And one of the examples I'll call out during our product demonstration today is the need for continuous monitoring and how a flawed release can impact normal production functionality. And then finally, DevOps is in the mainstream. Tools that engineering and other ops teams will use are still fragmented, and that slows down troubleshooting and key services availability. And I'll call out where that stands as we walk through the demo. So Wavefront is a Saas-based metrics-driven monitoring and analytics platform. And so we have many customers such as those running cloud native apps such as Box, Lyft, Intuit, Workday, and so on. And they'll use us to monitor the performance of cloud applications that have reached scale. So in the case of Box, we're talking at least 1 million data points per second, 1 million TPS that is. So we can inject that into our platform at that rate, and we can give people results back in a second or two, depending on how fast their networks are on premise. We're going to collect and analyze those metrics, whether we're talking about applications or containers or whatever, and it can be either in a public or private cloud. This is AWS, as you can tell on the slide. This is Google Cloud Platform, and you'll see many others as we walk through our various integration points today. We'll do it at scale, and we'll do it quickly. So, given this, we have advanced query-driven analytics. It isn't just data itself, it isn't just metrics, and I'll talk about what those metrics are in about 5 minutes, but the gist is, if you have a bunch of data flowing in, and you're trying to draw some correlation between the data that's flowing in and something you want to determine from it, whether you're talking about an average performance, or whether you're talking about a moving minimum or a moving maximum, et cetera, we have many, and we're talking at least 100 mathematical transformations available for you to work with your metrics data. And then based on the way you transform it, whether you want to see, what's the standard deviation between point A and point B, what is our average between point A and point B, or over a longer series of time, it allows you to troubleshoot the issues faster. And again, because we're SaaS, we offer that massive scale and high availability, and it's not like you have to build something, whether it be a purchase solution or open source solution on premise. We will scale things appropriately, and you will never, is completely transparent in terms of the way we deliver our service to you. Further, we offer customizable and shareable dashboards. One of the things that is going to be at the heart of our product demonstration today is how we land with, if you have a certain state in the dashboard, how do you share that with coworkers? Because we know that organizations can be siloed, even if you have a robust DevOps practice going on. And then finally, we're going to talk about intelligent alerting and proactive monitoring, and we're going to be detecting leading indicators quickly, or we're going to be quickly able to zero in on some kind of anomaly in the data, and these various charts will show you, and it's based on any kind of condition you define. So let's quickly talk about the ways people get data into Wavefront before we move into the product demo. So you'll see here at the center of all this is a Wavefront proxy. Wavefront proxy is literally based on a specific token you're given when you sign up for Wavefront, is going to say, okay, here's my jumping off point between the data I've collected, the metrics I've collected, and it's going to put that into the Wavefront platform via, because it's a SaaS solution, into our platform itself. And then you see these concept of Wavefront agents to the left. And if we're talking about systems, or if we're talking about various applications, maybe say Apache Tomcat, for example, these applications are going to be delivered to you through a telegraph agent, and or it's going to deliver data to the proxy through a telegraph agent rather, and then you'll see the data flowing, almost immediately into the Wavefront platform. And then, if we're talking about something like an AWS and so on, what you're going to find is that you're going to use something like CloudWatch or a CloudTrail directly to get the data into AWS. So that is our starting point to get data into the platform. And I want to stress, as we talk about this, I'm going to show this slide only briefly. You see many of the usual suspects in technology. You'll see, a Python and a Puppet. And you'll see Linux and VMware, Windows, Google Cloud, etc. It doesn't really matter if what you see on this page right here doesn't match your use case. So long as we can ingest the metrics, we can do something with them. And that's a highly desirable part of Wavefront, because we'll help you build custom dashboards. We will help you do anything you need to leverage these metrics and really rein in these real-time events, whether it comes to a DevOps team or your ops team or someone else who's getting paged in the middle of the night, to make sure that what they are analyzing is accurate. When they have to report to their manager in the future as to what the root cause was, they'll be able to tell them so effectively, and so on. So let's jump into the demo, and I'm going to start with the integrations we had just talked about. You'll see here that, again, to the earlier slide, things like AWS, Google Cloud Platform, Azure, Kubernetes, Linux host. I'm going to take one that's not something that everyone uses, but we have that concept of filtering by name. And in any of these integrations here, whether we're talking about Kafka or whether we're talking about a Linux host or et cetera, they all follow the same model in terms of integration. So you'll have an overview. Those details are self-explanatory, and I don't really want to, beat that drum too hard. Setup gives all the technical details of how to install the Wavefront proxy and a telegraph agent, and how to set up any kind of conduit between, say, a JMX log or a JVM log rather, and getting the data through the Wavefront proxy in a way we can consume. And then you'll see metrics and dashboards. I'm going to dive into that a little more, but I want to show you Kubernetes next, because many people use it. It's it's super widely used, and it's super robust. And actually, I'd say probably over half my customers have some Kubernetes need or another. So if we go to Kubernetes and we talk about setup, what we're going to get here is when you're deploying via Kubernetes, there's a proxy.yaml file, and there are really two key sections here: the Wavefront URL and the Wavefront token. And so for your environment, when you log in to Wavefront trial, whether it's try.wavefront.com or cs.wavefront.com, where I'm logged in right now because that's our customer solutions system, you're going to get the proper URL. So it could be try.wavefront.com, it could be a production one, etc. And you're also going to have a unique token or tokens for logging in. So you'll put those in your proxy.yaml file. Then you're going to run kube control and then give it the path to your proxy.yaml file. You're going to create some kind of Wavefront proxy service, and the same really holds true here. And then you're going to deploy Heapster in very much the same fashion, where you'll have a heapster.yaml, and then you're going to do kube control create given that Heapster YAML file. And this is extremely consistent. You can literally copy and paste from this page, and most customers have this running in a few minutes at most. Also, when you do a trial with Wavefront, it can be guided by an SE like me, where you can sit on the phone with me for 5 minutes, 10 minutes, an hour, whatever. We want to make sure all these integration points are properly covered when we go into various use cases with you, so we haven't left anything out while you're trying our platform. So now let's take a look at these dashboards. And this one is for Kubernetes. Typically speaking, I'm on my home internet connection right now. I have a pretty decent pipe, but even so, we're talking about a second or two to redraw everything. What you see here are a bunch of charts, and where these charts come from, to go back to the integration briefly, is that we've selected a bunch of these metrics. And if you type in something like a CPU, for example, you'll see like a CPU limit, CPU request, CPU usage rate, et cetera, et cetera, et cetera. And these dashboards are a collection of these metrics put together in a single source. So as we walk through the top of the page right here, I'm using a 6-hour window. You can do a 10-minute window if you want. You can do a 2-hour window up to 8 days by way of this dashboard view. And then you see all these fields up top here. You'll see a cluster namespace, nodes, pods, and pod containers. As you build a dashboard, if one doesn't already exist for you, you're going to be defining what each of the subsections are called. And certainly, you can consolidate all these as I'm doing here. Or if you don't want to consolidate them, you can simply click through and it'll take you to the corresponding part on the page. But there are a couple of other things that are super interesting with this. And the number one thing is that the analogy we all like to make at Wavefront by VMware is that you have this concept of signals and noise, or needles and haystacks. And if you think of a haystack, let's say you're working in a farm, you have a gigantic stack of hay. Someone goes, I dropped a needle into the middle of it, but I need that needle back. You need a magnet to pull it out, probably, or something else. You could just probably rip all the hay away, but that takes time. So what we do is to say, all right, we're trying to find the quickest path to get a needle from a haystack. So let's say that someone has determined that, yeah, my CPU usage rate by node, as you'll see here, is suddenly spiked at some point. And so by simply mousing over this single chart right here, and you'll see as I work through, this is all time locked. You'll see my cursor essentially moving here and there. I'm going to command click it. I'm on a Mac right now. There we go. Going to command click that guy, and you'll see that all the corresponding charts have drawn in the same way. And as we mouse over this specific chart right here, you'll see that the filtration has taken place. And it isn't just one. It could be multiple lines you're looking at in terms of CPU utilization or in terms of anything else. Let's just pick this one for fun. And you'll be able to, filter based on this data right here. The same holds true if you are going to zoom in between, say, 10-ish and 11-ish a.m. You're going to drill into this chart right here, and then there's this crisscross arrow on this chart, and you're going to click it, and you'll see that everything basically redraws to that point in time. Now, there's something interesting here, and I'm not going to go too overboard with this at the second because I have a certain amount of time, and we're going to revisit this anyways. You'll see on the right-hand side of the page this link. And so if you've used something like a bit.ly in the past or even now, you'll see the short form URL. We're going to dive into this in the next example. But the idea being, with this link here, I have zoomed into a certain point of time on these charts, and I want to take these results and share them with coworkers. So I had mentioned siloed organizations in the past, and I've certainly worked for many of them, given my time in IT for many years. And sometimes people have different monitoring systems and are looking at different types of data. So when big problems occur, people aren't really prepared to look at the same set of data in the same way. With Wavefront, it doesn't matter the platform, so long as the data is there, everyone can share the same view. And so let's move on to the next chart here. This is your typical KPI graphing, and this is a key performance indicator. So as we walk through there, as a transactions per second, there's a correlation, there are request latencies, and so on and so forth. But the real important stuff happens up at the top of this dashboard right here. And I want to walk through that. But the context is going to be in KPI transactions per second. So one of the things as a former IT guy that really drove me crazy was when someone would say, well, the application or the system is slow, but no one would ever really be able to back it up with data. And so I'd look at my graphs, and other people would look at their graphs, and other people would look at their graphs, and we were never able to quickly kind of make that correlation between some kind of drop-off in something, whether it be a system, whether it be CPU, whether it be memory, or whatever, or even a code deployment for that matter, and correlate it to where we are with a degraded transactions per second. So here we see that the key performance indicator of transactions per second has dropped off somewhere. And then we see this other chart here for correlation. And I'm going to keep my mouse over this for a couple seconds here. You'll see all the usual suspects: disk bytes written, cache hit percentage, network packets received, number of processes, disk space used, and so on and so forth. And this is literally everything as far as these correlations go. Now, to the naked eye, and I actually have pretty close to 20/20 eyesight these days, to me, just even mousing over this chart like I had in the previous example with Kubernetes and pinning various lines on, trying to pull that needle out of the haystack for various performance characteristics, I can glean nothing from this. So what I see here is that we have this known performance indicator dimension. We have total, we have by customer and by app server. Let's just take a look at by customer for a second, because with by customer, it really changes the dynamic of what we're looking at. And the semantic here is, let's say that you're hosting for a bunch of customers. You're hosting some application or set of applications for a bunch of customers, and you want to know how many customers are impacted. Totally common thing, been through it many times myself. And as we mouse over this chart right here, even in actually specifically in the degraded part, you'll see there are 5 customers. So 5 customers have been impacted by this performance issue. And as a result of this, you say, okay, this is bad. We know we have a problem, but now where's the problem happening specifically? So we're going to go one level deeper. We're going to go by app server. And by app server, because we knew we had a bunch of apps before, we knew we had 6 app servers. Notice what's happened here as we drill into this chart of KPI transactions per second. We've noticed that the only outlier in all these colors is the app server number 5, who's purple. And so we're going to take another step, because correlation is still not showing us anything. We're going to first drill into the app server. That's app server number 5. You'll see similar things happening because we're still on by app server. The correlations still don't tell us anything exciting, but let's take a look at our transaction count and our correlations. And sure enough, the transaction count verifies what we're seeing in our transactions per second. There's been a huge drop off somewhere between 10:05 and 10:10 a.m. So there's a second thing we can do here that's really interesting. We're going to do a correlation, and let's go back to the old data for a second. This is all of our data. We see, various prognosticators, disk bytes read, requests, total requests, et cetera, et cetera. Let's do a correlation between all of that and our transaction count. So this is going to draw, there we go. And then here's our transaction count. Now, we see 2 key indicators here, and you see there's a spike in certain activity while there's a degradation in transaction count. What we see is a bunch of log errors have ramped up, and a bunch of garbage collection count has also ramped up during this point in time. This is based on real customer data, by the way. This is one of our customers who had said, okay, well, we have this situation. How can Wavefront help us solve it? And we helped them out with the queries and so on. So now let's say I'm an IT operator and I say, okay, well, look, I want to take this link as an operator. I've dug through this dashboard and I understand what the correlation is between the degradation and our transactions per second and our correlation of, increased activity in garbage counts and so on. Okay, let's move over here. We're going to paste this into a new tab. Let's say I emailed this to someone or send it to them through Slack or whatever, and then we're going to wait for this to load. Everything drew exactly the same in the link that I sent to my operator or to my other app developer or whomever. And this is amazing because it doesn't give people that raw, key performance indicator dashboard and say, okay, well, look, if you really drill into between 10:05 and 10:10 and you click this and you click that and you click the other thing. No, this gives them that literal exact state you're talking about. And that's really a huge benefit away from both these things is being able to pull that needle out of the haystack very simply, because you saw how fast it redrew even on my home connection, and also give people the same view of a set of data. Let's talk about another scenario. And I had talked about DevOps earlier and how everyone used DevOps, or many organizations use DevOps. And what tends to happen is that because things move quickly, sometimes you get an undesired side effect from something that's routinized, such as deploying code. So there are a couple of examples here I want to show you, and I want to explain what these are. So you'll see this dashboard where you have something called CPU loads, and you'll see somewhere around, looks like 9:15 p.m. Actually, it is 9:15 p.m. You'll see a code deploy that's been called out, a new version of the code, and then you've suddenly seen that CPUs have spiked upwards. Now, from this chart on the top, there's a ton of noise, and I'll mouse over this for a second because you see a bunch of application clusters, and with the application clusters alone, you can't glean anything from it, no matter how good your eyesight. But there's an interesting thing that takes place here, and I want to show you this detailed view because this is really what puts it all together. This detailed view takes the Wavefront query language and does some interesting things with it. So the CPU load average is literally, as we have in this query builder here, CPU load av 1 minute. We're taking an average of it, but then you notice that something really creeps up at 9:15 or so, which more or less corresponds with the code release. But what people want to do, and Wavefront does things both ways, it can do both. Show me how things looked an hour ago, show me the way things looked 24 hours ago, show me a forecast for the future, which helps people scale applications and systems and so on. I have this new query. As you can see here, there's a lag function that says, from 24 hours before now, did we have the CPU spike? Because some of the developers are like, yeah, I don't believe you that CPU spike happened after the code deployment or during the code deployment. And you're like, yes, no, 24 hours ago. And if we take that on its own, you see there is no spike, okay? And so if you compare apples versus lagged apples, or apples to oranges, if you will, because that's orange, what you'll get is there's no spike here. And this is amazing because through this trend, you're able to determine that there's been some delta and that something has obviously changed in a way you hadn't intended. So I want to talk about alerting for the next 10 or so minutes before we turn things over to Q&A. So let's go into alerts first, and let's click Create Alert. And whether you're in a Wavefront trial or using the product right now, or you're interested in it, it doesn't matter. This toolbar rather up top is always going to be the same, whether we're talking about a dashboard or you can clone an existing one, create an alert as I've done here in integrations or browse, all the same. So there should be no worries with that. We have this query builder, and I'm going to scroll this up a bit so as I type things in, the scroll won't fall off the screen. When you click on a condition, and in this case, we're going to be looking at a request latency. And again, to the point of slowness, there we go. I typed in latence, that's going to do completion of this field. To the point of slowness I'd mentioned earlier, sometimes or frequently something is slow or something is down and people don't understand root cause. And also, in a post-mortem, people will ask you, well, how did this happen in the first place? And sometimes it's tough to wrap your head around. If you know the environment well, but you don't remember what happened a year ago, Wavefront takes you in that direction. So we're going to do a request.latency, and we're going to do And so I just clicked into the next field here, and you'll notice that it's kind of the same thing we're talking about. You have a bunch of app servers, it's a bunch of noise, and to the naked eye, some things seem high, but then again, maybe they're not. We're going to do an aggregation of average. And let's click back into that a second. Actually, let's get rid of it. Let's click through it, aggregation. And then for anything you do in the Wavefront Query Builder, it will tell you exactly how to use the function, okay? So what we're gonna do is we're gonna say that we're gonna just take the average, and we have this average latency, and then, you know, we're going to suggest, okay, we're going to give some number just for the sake of seeing things change. Let's try something else here just to see how the graph looks. So we have nothing that crosses 200. Let's go 160. All right. So this is what I'm talking about. The reason why I changed this number a couple times is that the idea behind the data we are working with in real time and the kind of alerts you want to fire is all based around what that threshold is that you might want to or might not want to cross. And I can tell you firsthand, as someone who's been on call for both, you know, your basic IT organization or a DevOps team, being paged a million times for something that's a faulty alert causes kind of, you just don't want to be paged at 2 a.m. for something that you know you could change the threshold or get a more accurate reporting of. And so what we have here is, yeah, you know, we're taking a look at the average request latency of this over 160, and you can tell the graph is totally flat otherwise, but it's all based on the organization. Certainly you're going to want to give the alert a name. Well, let's get into the meat of what we're doing here. So there's a severity available, severity in terms of severe, warn, smoke, or info. And you can do your typical targeting of, yeah, I have, you know, someone at some company is my email. It could be whatever. It could be a mailing list. You can have your PagerDuty key here. And then I had mentioned this earlier briefly when I'd gone through the slides. You can do an alert target that's essentially a webhook. It can be a Jira. It can be a ServiceNow. It can be a Nagios. It can be really anything, so long as it provides a webhook to us where we can say, hey, something's gone wrong here at some point in time. As far as other things you can look at, so we can get rid of this graph right here. So we have a request latency. We can take a look at really anything. You know, you can scroll through this whole list of functions and glean something from it. And also you'll notice that it lets you set greater than or less than, because in some instances, if you're talking about HTTP requests, as an example, if you're taking in less than or equal to a certain amount of HTTP requests, obviously that's not the desired effect. So, and you can say, you know, my lag is, I doubt anything's going to draw from this, but just to illustrate a point, so nothing's going to lag. So yeah, I mean, obviously Wavefront has a ton of options when it comes to, you know, filtering data out of us and trying to figure out, you know, how am I going to monitor it? What am I looking at? And so on and so forth. So that is the gist of Wavefront itself. Since we have about 20 minutes left, can we turn over to Q&A, Carolyn?
Yeah, so everyone, if you have any questions, feel free to type them into the chat window. I notice a few have been coming through during the session. So if you have any questions, just type them in. And then Nate, you can read them off and answer as we go. Okay, I see some more questions coming through. Awesome, yep, keep them coming. We'll try and answer as many as time allows for.
All right. Okay, let's start with Dimitri. This came in at 1:11 p.m. Eastern Time. Wavefront agents are installed inside VM's guest OS. So the answer is yes, they can be if you want to be monitoring the VM's guest OS through whatever template you're using. If you're using, VRA, vRealize automation to deploy that, if you're deploying a container, even all the Wavefront configuration will be deployed during provisioning, or you could deploy an agent by way of the command line later on if you're talking Linux or even through Windows. And then there's a second question from Dimitri. NSX plus VRNI and PKS, is it possible to add Wavefront to this demo environment? Where do we store all those raw data, in cloud or on-prem? If in cloud, what are the requirements for minimal BW, delay, and jitter for WAN link? So the answer for PKS specifically is that, let me go over here to my integration screen and we'll take a peek at what we got. PKS, as you can tell here, move this chat out of the way, you'll see Pivotal Cloud Foundry. So the short answer is yeah, we certainly do support PKS, and the integration notes are in there. All of the raw data goes from a container into the cloud. So what happens is that if for whatever reason you lose access to a system or to a between a container and the proxy, all of that gets flushed when things come back online. So the data points aren't lost. It's just a matter of understanding that before that data ends up back going through the proxy, you're not going to see it. Is there something like recommended troubleshooting approach to solve application? This is also from Dimitri. Is there something like recommended troubleshooting approach to solve application performance problems? For example, in networking, we have at least 3 different approaches: bottom up, bottom, hybrid. So what I recommend, Dimitri, is that if you haven't done a POC with Wavefront, you do one, and we talk through various use cases you'd like to solve. The typical POC trial is 30 days. And if you're still working through it, we'll work with you to make sure you can get out of it what you need to. I think defining the problem you're trying to solve and having us write Wavefront queries around it with you is the best way I've seen customers solve the problem. So the short answer is, we've solved all kinds of customer problems, from arcane stuff to the more higher level stuff. And the Wavefront query language is super flexible to help you get to that point. And as far as recommended book on application monitoring, Wavefront in and of itself is so performant, and with its real-time results, I'm not sure that a book in and of itself, like a more generic implementation of time series-based monitoring, would be effective. I think that Wavefront is really in a class of its own, and we certainly outperform most of our competitors in terms of throughput. So the number one thing is do a time trial. So to Bob's point, or Bob's question, yeah, there are certainly network infrastructure devices, and so as far as network infrastructure devices go, if we don't support infrastructure piece, and let's go in here, Cisco. If we don't support it out of the box, so long as you can put data into the Wavefront platform, you can get metrics out of it. So what will happen is you deliver data into Wavefront, and then we'll create a dashboard for you where you'll be able to do something with the data. So it doesn't matter what the data is. You can have a custom application. We have customers that do this all the time. I'm using JVMs as an example because this is a common thing I see all the time. They'll deliver data into Wavefront, and then we'll take a look at the metrics, and then we'll figure out what they're doing. And then we'll write a dashboard around that, and it's super straightforward. And Cisco stuff works in the same kind of way. And then Dimitri asks again, how do we compare with App Dynamics from Cisco? Oh, Dimitri, there are no Wavefront images. What you're doing is integrating at a higher level. Either you're going to integrate with the container or you're going to integrate with PKS, because we're Saas-based, so there's no image or anything you have to download to get Wavefront running. And as far as a comparison to other products, Wavefront's big thing is performance metrics, and it isn't just app performance. It is apps, it's containers, and systems and microservices. So it's quite different in scope than some of the other products in the market.
Any other last questions here? Alrighty, well, if you have any questions, you can feel free to reach out. It's wavefront@vmware.com is our email, or we also have a link to our free trial available on our website. Our website's wavefront.com. If you go to wavefront.com/sign up, or if you visit our website and click the big blue Get Started button, you can sign up for a trial of Wavefront. We offer it free for 30 days. We also are on YouTube and on Twitter, Slack as well. So you can reach out to us on any of those places. And again, as a reminder, we did record the session, and we will be sending it out to you tomorrow via email so that you can rewatch this video and also share it with others. So thank you so much, Nate, for joining us this morning, and we will give you guys all back a couple minutes of your day. So thank you.
Thanks, everyone. Thanks, Charlie.